Year 12, and welcome to Purple Mountain Education. Today we're doing the 2025 HSC paper for Maths Extension 1. This is part 5, question 14, worth 15 marks. Question 14a, prove that the product of any distinct factors of 60 must be a multiple of 60. Pause here to try yourself. Alright, so let's consider the factors of 60. So the factors of 60, factors comes from the same Latin word as factory, meaning to make. So the factors of 60 are the numbers that make 60 through multiplication. So there's 1 times 60, there's 2 times 30, there's 3 times 20, there's 4 times 15, there's 5 times 12, and there's 6 times 10. So the factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. But they're naturally grouped in pairs. Okay, so there are 6 pairs of factors. Even if we choose one from each of the 6 pairs, upon choosing the 7th number, it must match with one of the pairs already chosen. So, therefore, by pigeonhole principle, the product of any 7 factors of 60 will be a multiple of 60. Question 14b. Points A and B lie vertically above the origin. Point A is higher than point B such that OA over OB is K, where K is more than 1. A particle is projected horizontally from point A with velocity u meters per second. After t seconds, another particle is projected horizontally from point B with velocity v meters per second. The 2 particles land on the ground in the same place. Show that the ratio v over u depends only on k. Okay. Pause here to try yourself. Okay, I'm just going to draw this a little bit myself so I can see what I'm doing. This is point B, this is point A. I know that this launches at V and this launches at U. Let me derive all my equations for A first of all. So A vertically, I know that the second derivative is just going to be related to gravity, so negative gravity. The first derivative is negative gt plus my first constant. I know that at t equals 0, my y displacement equals 0, so that tells me that C1 is 0. So my first equation of motion there is just y dot equals minus gt. Now let me differentiate again to get to y. Y is negative a half gt squared plus some other constant which I'll call C2. I know that at t equals 0, my displacement is the height from O to A. I'll just call that OA for the time being. So y equals negative a half gt squared plus, well actually rather than calling it OA, I think I'd rather just introduce another variable. If I call this height h, then I can call this height kh, because I know that relationship between OA and OB. So let me call that KH. So my equation is minus a half GT squared plus KH. All right, let's work horizontally through what's going on with A. So the acceleration in the horizontal dimension is nothing. And I know that it's 0 at 0. So x dot must just be some constant. I know that at t equals 0, that initial speed is being given to us by u. That implies that c3 equals u. So my next equation there is that u dot equals u. Now get to displacement u. X equals ut plus my next constant. I know at t equals 0 that x equals 0 implies that c4 equals 0. So my next equation is x equals ut. All right, let's now work our way through what's going on for B. So for B, this is going to be similar but slightly different because we know that B gets launched after t seconds. But let's just work vertically through B and then we'll work horizontally. Okay, when I work vertically through B, I know that y double dash equals minus g. I know that y dot equals minus g t plus some constant I'll call c5. Now, at t equals t, y dot equals 0. Therefore, minus gt plus at when t is capital T plus c5 equals 0. That tells me that c5 is g capital T. So I've got an equation for y dot as minus gt plus g capital T, which is minus g outside of t minus capital T. I can differentiate again. I get y equals minus a half g t minus capital T squared plus my next constant, C6. Now I know at t equals capital T, the y displacement is given by OB, which I've decided to call H. So I get the fact that y equals minus a half g t minus t squared plus H. Okay, let's work out horizontally. X double dot equals 0. So x dot is some constant which I'll call C7. I know that at t equals capital T, the velocity is given by capital V. So that implies C7 equals V. So my first equation is x dot equals V. Now let me differentiate one more time. X equals Vt plus my final constant. I know that at t equals capital T, the displacement is 0. So it must be the case that C8 equals negative Vt. So I've now got my final equation, x equals Vt minus Vt. It's T. If I want to pull out my V, it's little t minus capital T. Okay, let's use those equations of motion now that we've got them. We know that it hits the ground when y equals 0. YB equals 0. So let me just take the equation that I had for A was minus a half GT squared plus KH equals 0. So I've got a half GT squared equals KH. T squared equals 2KH over G. So T must be the square root of that. Okay, that's useful. And we also know our equation for x equals ut. So let's find where that is at that time. So xa equals u times that t value. Now let's consider what we know about when yb equals 0. So if yb equals 0, yb is minus a half g t minus capital T squared plus h. And if that equals 0, t minus capital T squared equals 2h on g. So E minus capital T is root 2h on g. T equals capital T plus root 2h on g. All right, the x-coordinate for B equals Vt minus capital T. So it equals V, that T is T plus root 2h on g less T. So it equals V root 2h on g. All right, so I've got an expression for the x-coordinate for A and an expression for the x displacement of B. I'm going to equate those because we're told they hit at the same point. So just equating those expressions. Equate xa equals xb. So we know that u root 2kh on g equals v root 2h on g. So v over u, which is what we're interested in, equals root 2kh on g over root 2h on g. So root 2kh on g times root g on root 2h. So much of that is going to cancel. I'll just be left with root k. And I was actually asked to show that the ratio v over u depends only on k. So I'm done as required. Question 14c. The hands of an analog clock are OA and OB, where A has coordinates sine pi t on 360 cos pi t on 360, and B is 2 sine pi t on 30, 2 cos pi t on 30. O is the origin, and t greater than or equal to 0 is the number of minutes past midnight. Find the values of t where the hands are perpendicular for the first and second time after midnight. Give your answer to 3 decimal places. Pause here to try yourself. Okay, so the key to unlocking this question is to know that perpendicular implies that the dot product is 0. So let's go ahead and work out the dot product using the coordinates we've been given. So 2 sine pi t on 360 sine pi t on 30 plus 2 cos pi t on 360 cos pi t on 30, that equals 0. All right, we can pull out that 2. We can also recognise sine plus cos is the structure I need to use cos of the difference. So pi t on 30 less pi t on 360, which is 0. So if I was to simplify that fraction in there, to turn 30 into 360, I've multiplied by 12, so multiply the top by 12. So it must be cos of 11 pi t on 360, which equals 0. All right, let's think about all the times when cos of an angle equals 0. So I've got 11 pi t on 360. It must be equal to pi on 2. There's no point doing minus pi on 2, but I could think about it that way, minus pi on 2 and plus pi on 2. Now add 2 pi to that, I get 3 pi on 2. I get 5 pi on 2, and so on. I have all the odd numbers of pi on 2. I need t to be positive, so there's no way of considering that. The first one after midnight is going to be when it just equals pi on 2, and the next one after midnight is going to be when it equals 3 pi on 2. So simplifying all that, t equals 360 divided by 2 times 11, and that one is 16.3636, or approximately 16.364, and this one, t equals 3 times 360 on 2 times 11, so this one is 49.091, and they're my two answers. They're in minutes. Question 14D. The function f of x is defined by f of x is inverse cos of sine x in the domain 0 to pi. Find f dash of x for those values of x where it is defined. Pause here to try yourself. All right, so let's just remind ourselves. Yeah, so reaching for the reference sheet to remind ourselves how to differentiate inverse cos, given that f of x equals inverse cos of sine x, then the first derivative, I'm going to get 1 over root 1 minus sine squared x, and the numerator is going to be cos x because of chain rule. So I've got minus cos x over the square root of cos squared x. So that's minus cos x over the absolute value of cos x. So that's going to be either plus or minus 1. And let's see where that's the case. So for x between 0 and pi on 2, we know that cos of x is positive. Therefore, here, f dash of x is going to be minus 1. And for x between pi and 2 and pi, we know that cos of x is negative. Therefore, here, f dash of x is going to be plus 1. And at exactly x equals pi on 2, we know that cos of x equals 0. Therefore, the first derivative is undefined here. And so those two will give me my answers. So just recapping my answer, I'm going to get f dash of x equals minus 1 for x in this range, and it's going to be positive 1 for x between pi on 2 and pi, and that's my answer. Question 14e, it is given that tan alpha, tan beta and tan gamma are the three real roots of a polynomial equation as shown, where b and c are real numbers and c is not 1. Find the smallest positive value of alpha plus beta plus gamma. Pause here to try yourself. All right, let's first of all get our equations. Sum of roots, which is tan alpha plus tan beta plus tan gamma, and that equals minus b on a. In this context, I can see that a equals 1, so that just equals minus b. Let's call that equation 1. Let's look at our sum of products of roots. So tan alpha tan beta plus tan alpha tan gamma plus tan beta tan gamma equals c on a, which equals c. Call that equation 2. And let's do our product of roots. Tan alpha tan beta tan gamma equals minus d on a. Which equals minus outside of that d term, which is minus 1 plus b plus c. So tidying that up a little bit, that's 1 minus b minus c. And we'll call that equation 3. All right, we're interested in the smallest possible value of alpha plus beta plus gamma, but it might be worthwhile to work out tan of alpha plus beta plus gamma. So let's go ahead and do that. Tan of alpha plus beta plus gamma. Using our formulas, that's tan of the first term, which I'll group that at alpha and beta together, plus tan of the next one, all over 1 minus tan alpha plus beta tan gamma. Okay, let's expand out that next tan of an angle sum. So giving myself some room to do that. It equals tan alpha plus tan beta on 1 minus tan plus tan gamma all over 1 minus tan gamma times tan alpha plus tan beta all over 1 minus tan. All right, I'm going to make 1 minus tan alpha tan beta the common denominator. So my numerator is tan alpha plus tan beta plus tan gamma outside of 1 minus tan alpha tan beta. And all of that is sitting on a 1 minus tan alpha tan beta. And the numerator, I'm just going to do a similar thing. 1 minus tan alpha tan beta minus tan of gamma outside of tan alpha plus tan beta. And all of that is sitting on a little denominator there of tan alpha tan beta. So I can get rid of those little denominators and I can rewrite the numerator as simply tan alpha plus tan beta plus tan gamma less tan alpha tan beta tan gamma all over 1 minus tan alpha tan beta minus tan alpha tan gamma, also minus tan beta tan gamma. So now I get to use the equations that I had before. So the first piece is the sum of roots, and I know that the sum of roots equals minus b. take away the product of roots, which I know is 1 minus b minus c. And then I've got 1 minus the sum of the pairs of roots, which is c. So just tidying up that a little bit, I've got minus b minus 1 plus b plus c all on 1 minus c. The b's go away. I get minus 1 outside of 1 minus c on 1 minus c. So I just get minus 1. So I've established that tan of alpha plus beta plus gamma equals minus 1. So it must be the case that alpha plus beta plus gamma equals minus pi on 4 or 3 pi on 4, but they asked me for the first positive value. So the answer is 3 pi on 4. Thanks for listening to Purple Mountain Education. Well done for making it to the end of the paper. Like and subscribe for more.